Hello everyone, once again welcome to Mathline channel. In this channel you will be getting a basic maths lesson every week. Those who have not watched the previous lessons, please watch from the beginning and continue watching. So let us start today's lesson. We were learning theorems and proofs. Today, I would like to explain the theorems on the properties of square. The definition of square is the quadrilateral with all the sides are equal and all the angles are equal, then the quadrilateral is a square. Therefore, since all the sides are equal, opposite sides are equal, therefore square is a parallelogram. So all the properties of parallelogram are applicable for the square also. That is, opposite sides are congruent, opposite angles are congruent, then diagonals bisect each other and their converses also. Also, square is a rectangle because all the angles are 90 degree. Therefore, the property of rectangle that diagonals are congruent is also applicable for square. So, diagonals are congruent. So, the proof of these theorems we are already done. Similarly, we have to do. So, which of the properties now? Opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, diagonals are congruent. Also, the diagonals of a square are perpendicular bisectors. That is, square is a rhombus also. So that theorem also applicable in the case of square. Diagonals of a square are perpendicular bisectors of each other. Therefore, there is no new theorem or that is only applicable for square is not there. And also, the converses of these theorems are not applicable for square. For example, opposite sides of a square are congruent. That is true. That theorem we can prove. But look at the converse. If opposite sides are congruent, it is a square. This is not true. Its converse is not true for square. Similarly, opposite angles are congruent in a square. That theorem that is true. But the converse, if the opposite angles are congruent, it is a square. That is not true. Diagonals bisect each other in a square. True. If diagonals bisect each other, it is a square. Not true. So converse is not true. Diagonals are congruent. True. But if diagonals are congruent, then it is a square. Not true. That is only rectangle. Clear? Similarly, diagonals are perpendicular bisectors for a square. True. But if diagonals are perpendicular bisectors, then it is a square. It is not necessary that it is a square. Can be rhombus also. So, the converse of these properties, theorem with these properties are not true for square. Because property of square is all the properties of square are not satisfied for rhombus, parallelogram, rectangle, etc. But all the properties of parallelogram, rectangles, rhombus are applicable for square. Therefore, the converses of these properties are not applicable for square. But only this we can say. If diagonals are congruent and perpendicular bisectors, then the quadrilateral is a square. If diagonals are congruent also, perpendicular bisectors also, then it is a square. That we can prove because we can prove if it is like that. All the four triangles are congruent and therefore corresponding sides are congruent, all the sides are congruent. Similarly, you can prove ABD congruent to CBD, therefore angle A congruent to angle C. So all the angles are also congruent, you will get. So what it is true? If the diagonals are congruent and perpendicular bisectors, then the quadrilateral is a square. Clear? That is true for square. Therefore, no separate special theorem for square. Square is the quadrilateral with all the properties of parallelogram, rhombus, rectangle are applicable in the case of square. That is, square is a special type of quadrilateral. Understood? The theorems in the square are what? Opposite sides are congruent, opposite angles are congruent, diagonals bisect each other, diagonals are congruent, diagonals are perpendicular bisectors of each other. And which is true? Which converse is true? If the diagonals are congruent and perpendicular bisectors of each other, then the quadrilateral is a square. So there is no separate theorem for proving, because similarly we proved all these properties in the other cases of quadrilaterals. Clear? So just to remember, suppose in the exam it comes, you have to prove similarly. Suppose it comes opposite sides of a square are congruent, prove. So you have to use the same method as it in the case of parallelogram, since square is also a parallelogram. Understood? So that is about the theorems on the properties of a square that I would like to explain today. Thank you for watching this lesson. Please watch each and every video of Mathline from the beginning to end for better understanding. Also continue watching. Also share and forward to maximum number of students of all standard. See you next week with a new topic. Have a nice day. Bye bye. See you.